एवरीवन, वी आर बैक अगेन विथ अनदर वीडियो। हमने हमारी पहली वीडियो में हिस्टामिनिक ड्रग और उसके रिसेप्टर का क्लासिफिकेशन देखा था। नाउ इन आवर सेकेंड वीडियो वी आर गोइंग टू सी H1 एंटागोनिस्ट and their classification and their SAR. So let us begin. So H1 antagonists. H1 antagonists are classified into two types, first generation and second generation. So in the first generation there are again 6 types: ethanolamine, ethylene diamine, alkylamine, which is also known as propylamine, phenothiazine, piperazine and others. An example for each class is given, and to memorize this example along with their classification is an important point as per our exam. हमारे एग्ज़ाम के अकॉर्डिंगली देखा जाए तो हमें इसके एग्जाम्पल्स याद रखने हैं और एग्जाम्पल्स और उनकी स्ट्रक्चर और कुछ ड्रग्स के सिंथेसिस भी याद रखने हैं. सो लेट अस बिगिन विथ आवर एग्जाम्पल्स. सो इथेनॉल अमाइन. इथेनॉल अमाइन के फ्यू एग्जाम्पल्स है: डाइफिनहाइड्रामाइन, डाइमेनहाइड्रिनेट, क्लिमेस्टाइन. इथिलीन डायमाइन, एंटाजोलाइन. फॉर प्रोपेनाइल अमाइन, क्लोरफेरेनामाइन मैलेट. फॉर फिनोथायाजाइन, प्रोमिथाजाइन. एंड फॉर पेपराजाइन, cyclizine and meclizine. And others means or miscellaneous we call cyproheptadine. Now in the second generation of H1 antagonist, the examples are loratadine, terfenadine. So now let us look at some of the examples and their mechanism of action and their synthesis. So हमारा सबसे पहला एग्जाम्पल दैट इज़ फ्रॉम इथेनॉल अमाइन क्लास, दैट इज़ डाइफिनाइल हाइड्रामाइन HCl. सो लेट अस लुक एट द मैकेनिज्म ऑफ एक्शन ऑफ डाइफिनाइल हाइड्रामाइन HCl. सो देयर मैकेनिज्म ऑफ एक्शन इज it is an inverse agonist of H1 receptor and it acts as an antimuscarinic and an intracellular sodium channel blocker. So how does it work? It works as it gives an antimuscarinic effect as well as an intracellular sodium channel blocker. So by reversing the effect of histamine on the capillaries, it can reduce the intensity of allergic symptoms. So how does the diphenylhydramine works? Simply it works by reversing our effect of histamine. As it is an antihistaminic drug, obviously it will reverse the effect of histamine. But where it is reducing the effect of histamine or reversing the effect of histamine? On the capillary, and hence due to that it reduces the allergic symptoms. Now we'll look at the uses of diphenylhydramine. तो diphenylhydramine के कौन कौन से uses है? Antihistaminic, it is an antihistaminic, antitussive and antiemetic as well as a sedative. So these are the main uses of diphenylhydramine. Now let us look at the synthesis. Diphenylhydramine का synthesis is important to learn as per exams. It is very frequently asked to us to write the synthesis of diphenylhydramine HCl. So what is the synthesis of diphenylhydramine HCl? Synthesis begins with diphenylmethane. When diphenylmethane reacts with bromine in presence of K2CO3, it gives diphenylbromomethane, which when further reacts with N-dimethylethanolamine gives us our diphenylhydramine KBr and CO2 molecule along with water molecule. एक बार फिर से देखते हैं. when our diphenylmethane ब्रोमीन से रिएक्ट करेगा, किसकी प्रेजेंस में? इसकी प्रेजेंस में रिएक्ट कर रहा है K2CO3. So it is forming a molecule that is diphenylbromomethane. फिर diphenylbromomethane again react करेगा N-dimethylethanolamine से. When it will react with N-dimethylethanolamine, we will get our compound that is diphenylhydramine HCl. So now let us look at the another drug, and that drug is triprolidine. So triprolidine reacts in this drug. The basic synthesis of this drug, let's begin. So first of all, 4-methyl acetophenone is reacting with CH2O in presence of pyrrolidine to form an intermediate compound, that is 4-methyl-3-pyrrolidine propanophenone, which further reacts to give another compound which on hydrolysis give triprolidine. This was the synthesis of triprolidine. Triprolidine is an H1 antagonist from our propylamine class, from our alkylamine, or we can say propylamine class. So the next example is promethazine synthesis. So promethazine is belonging to our H1 antagonist from phenothiazine class. So in this, phenothiazine molecule is reacting to another molecule in presence of NaNH2 to give us a promethazine molecule. The promethazine synthesis is very simple and easy, only in one step synthesis. So now we are going to learn see the SAR of our H1 antagonist. So how our SAR of H1 antagonist begin? So our SAR of this is our journal formula of H1 antagonist. In this journal formula, we can see two aryl groups that is attached to a X molecule, that is further attached to a spacer, that is ethyl molecule, and again to the nitrogen amino group. So फर्स्ट ऑफ ऑल हमें सार निकालने के लिए इसको डिवाइड करना होगा 4 पार्ट्स के अंदर. दिस विल बी अवर फर्स्ट पार्ट, एक्स विल बी अवर सेकेंड पार्ट, दिस विल बी अवर थर्ड पार्ट, एंड अमाइनो ग्रुप विल बी अवर फोर्थ पार्ट. नाइट्रोजन ग्रुप विल बी अवर फोर्थ पार्ट. सो let us begin with our first part, that is aryl group. So 2 aryl groups are essential. हमारा H1 histaminic antagonist के एक्शन के लिए 2 aryl groups essential है, and both aryl groups can be phenyl or any one can be a heterocyclic group. या तो दोनों भी aryl groups phenyl होंगे या उसमें से कोई एक heterocyclic group होगा to increase the activity. और इसका example है doxylamine which increases the activity. AR may be aryl methyl group which shows activity. AR dash मतलब aryl dash group जो है वो that is present here can also be a aryl methyl group that will also show a activity. The substitution of ClBrOCH2 group on the aryl group increases the activity. aryl group के ऊपर जब हम लोग क्लोरीन, ब्रोमीन या OCH2 ग्रुप ऐड करेंगे तो उसकी एक्टिविटी इंक्रीज होगी. उसका एग्जाम्पल है ब्रोमो डाइफिनाहाइड्रामाइन. डाइफिनाहाइड्रामाइन हमने अभी स्ट्रक्चर देखा. नाउ व्हेन अ ब्रोमीन ग्रुप इज एडेड टू अ डाइफिनाहाइड्रामाइन द स्ट्रक्चर इज गिवन हियर ऑल्सो इंक्रीजेज द एक्टिविटी. नाउ लेट अस डिस्कस अबाउट अवर सेकेंड, that is X. Second part, that is X. So X should be N, O or C, nitrogen, oxygen or carbon. If any other atom will be added, the activity will be less or least, means there will be no activity or there will be a less activity. So only nitrogen, oxygen and carbon atom has to be added to the X molecule. Now when our X molecule is N, so the drug obtained is from ethylene diamine derivative. When our X molecule is O, then our amino alkyl ether analog is obtained. When our X molecule is C, our mono amino propyl analog is obtained. So on the basis of N, C, O and C present at the X position, they are classified into the different types. Now let us discuss about now we'll look at our third part, that is our alkyl chain. So alkyl, it is also called as a spacer, which is between X and terminal nitrogen atom. So it branching or extension decreases the activity. So there should not be more branching present in this spacer which is between X and terminal nitrogen because this will decrease our activity. Homologation develops neuroleptin and tricyclic antidepressant for antihistamines. The C atom, which is attached to nitrogen atom, if it is branched, then it doesn't have any effect on the activity. So it can be branched or it can't be branched. It doesn't affect the activity. Now let's discuss about the fourth point, that is our terminal nitrogen atom. So for the maximum activity to be obtained, our terminal nitrogen atom should be tertiary amine, or our terminal nitrogen atom may be the part of a heterocyclic ring and retain high antihistaminic activity. If our terminal nitrogen atom is also a part of a heterocyclic ring, then also our antihistaminic activity will be seen and a high antihistaminic activity will be seen. So today we have discussed our H1 antagonist, its classification and its journal structure along with synthesis of some drugs. Now in the next lecture we are going to discuss our H2 antagonist receptor. So please don't forget to subscribe and press the bell icon for never missing an update, and please like the video.